Hello everyone, welcome back to Deviations. This is going to be a more to the point video. We're not going to do many examples, but today we are going to be covering the hyperbolic functions. These might sound familiar, but we are going to get into a little bit of the calculus of the hyperbolic functions in addition to introducing them as a concept. These hyperbolic functions aren't going to be extremely important in Calculus 1, but in Calculus 2 they're going to become vital to our understanding of some of the concepts that will arise in that part of the course. So let's just start off by giving some prerequisites for this video. In order for you to understand what I'm doing, I would recommend that you watch my videos on the chain rule and the product rule and the quotient rule and the power rule, as always, just that you're on the course here. All right, so what is a hyperbolic function? So what you're going to notice when I graph these is that they're not going to look like our normal trig functions. They're not going to look periodic. Like we don't have a wave here. We just have like a parabola, what looks like a cubic and a cube root. So those are our three main hyperbolic functions. We have the hyperbolic sine, cosine, and tangent. And basically with these hyperbolic functions, instead of using a unit circle to define these functions, we use a unit hyperbola. If you don't know what a hyperbola looks like, it looks something like this. It's like a double parabola almost, but they're not the same shape. It's going to look like that, and you can rotate it around. These can come closer and farther apart, and they can stretch and squish. So there are a lot of different ways we can manipulate a hyperbola, but these functions revolve around a plain old normal unit hyperbola, which is not what I've just drawn here. This is just a random hyperbola to show what it looks like. But we will get into the conic sections later in the course. All right, so let's define all six functions. Just like we had six trigonometric functions, we're going to have six hyperbolic functions. All right, so we can define the first one, sinh of x is going to be e to the x minus e to the negative x over 2. As you can see, we've got a little bit of Euler's number in here. We talked about Euler's number in the last video. And just like sinh, we can have cosh, the hyperbolic cosine of x. That's going to be e to the x plus e to the negative x over 2. So that's cosh. Fortunately, the other four functions don't have funny names, but I guess I could try. We could call hyperbolic tangent maybe than. And that's just going to be sinh over cosh, just like our normal unit circle functions. And then maybe I'll call this cosesh, the hyperbolic cosecant of x is going to be 1 over sinh of x. That's how it is in our normal trig functions as well, and it's going to be the same for the others. Sesh is going to be 1 over cosh, and then the hyperbolic cotangent, I guess we could call that coth, it's going to be cosh over sinh, or 1 over tan. All right. So those are our functions in the most pure of forms. Now let's try to differentiate each one of these. And we're not going to do any examples with this, but you should take notes because this might show up on your test or on a worksheet. I don't know, I'm not your teacher, so maybe. All right, so if I want to take the derivative of sinh, that's just going to be cosh. That's just like if we want to take the derivative of the sine of x, that's just going to be the cosine of x. And it's the exact same thing here. Sinh goes to cosh. All right. Cosh goes to sinh. So no negative sign because the derivative of the cosine is going to be the negative sign. But we don't have a negative here. This is a positive sinh. All right. If I want to take the derivative of than, that's going to be sesh squared of x. And that should be pretty familiar because the derivative of our normal tangent is the secant squared. All right, and if I want to take the derivative of cosesh, that's going to be negative cosesh times coth. So that's exactly the same as how we have it in our normal trig functions as well. And if I want to take the derivative of sesh, it's going to be the negative sesh times than. And here we have a negative. We don't have a negative in our normal trig function when we differentiate secant, but hyperbolic secant goes to negative hyperbolic secant times hyperbolic tangent. And then finally, for the derivative of coth, That's just going to be negative cosesh squared of x. All right, so those are the derivatives. Pause the video if you want to take notes on this. You should remember these. All right, now let's talk about the inverse hyperbolic functions. So this is going to be pretty theory-based, just like the rest, but if I want to take the arcsin, or the hyperbolic sine to the -1 of x, that's going to be the natural log of x plus the square root of x squared plus 1. Likewise, if I want to take arccos, that's going to be the natural log of x plus the square root of x squared minus 1. We have a minus there. Then if I want to take the arctan of x, that's going to be 1/2 times the natural logarithm of 1 plus x over 1 minus x. If you want to see what these look like, here's them on the graph, right? So it's just going to look like our traditional inverse functions. There we have arcsin, arccos, and then arctan is coming in there. All right, so that shouldn't be too surprising. It's just on a different axis, right? So now let's try differentiating these. So we're going to do all 6. And this is going to become really important in Calculus 2, because in Calculus 2, we're going to have the job of anti-differentiating, when we're going to need to anti-differentiate something like this. And as you'll see in Calculus 2, we're not really going to know how to do that, but there's going to be really helpful substitution where we can just say, oh, well, I know what that is. That is the arcsin of x. All right, but the derivative of the arcsin of x is 1 over the square root of 1 plus x squared. We have the derivative of arccos, which is of x, is going to be 1 over the square root of x squared minus 1. Then if I want to take the derivative of arctan, that's going to be 1 over 1 minus x squared. Then if I want to take the derivative of arccosesh, that is going to be -1 over the absolute value of x times the square root of 1 plus x squared. Then if I want to take the derivative of arcsesh, that's going to be -1 over x times the square root of 1 minus x squared. And finally, if I want to take the derivative of arccoth, that's going to be 1 over 1 minus x squared. All right, so as you can see, these hyperbolic inverse functions spit out some pretty common-looking rationals once we differentiate them. So that's pretty interesting. All right, thank you for watching. Next time we will be back to talk about implicit differentiation, and then we will use that to derive the derivatives of the normal inverse trig functions. All right, so stay tuned for that. That is coming later. See you guys later.